Beckman students. Today I will be reviewing the ticker tape practice homework with you. Hopefully this will be helpful for you to review to make sure you understand how to solve these problems. All right, so before we get into this homework, let's just review what ticker tape diagrams are, just so we have a background kind of information of it. So what is a ticker tape diagram? It's a diagram that describes the position of an object at regular intervals of time. So if you can go back here, I have an example of a live ticker tape. Here's what it looks like. And in this ticker tape, each little dot represents the machine kind of pressing down on this paper. Okay, and the space in between the dots is a certain interval of time, and that interval of time stays constant. The distance between the dots represents how fast the object is moving. So for example, over here, the object's moving really slowly because the dots are close together. But as I'm pulling the paper, I'm pulling it faster and faster, so the distance between the dots is getting further and further. In other words, I'm covering more distance for the same interval of time. All right? So let's go ahead and review the homework. In number 1, we're just going to be matching the ticker tapes with appropriate descriptions of motion. So starting from X, we know that we're moving from left to right. And what you notice about X is that the dots are evenly spaced. And so you know that this must be constant speed. In Y, again moving from left to right, we see that the dots start off closer together, which means it's moving rather slowly. It's not covering much distance in that given time interval. And it's getting further and further apart. The dots are getting further and further apart, which means that they're covering more distance for that given time interval. Therefore, that object is speeding up. Z is the opposite. We're covering more distance in the beginning, which means we're moving pretty fast. And then we're getting closer and closer together, meaning we're covering less distance per time interval. So this object is slowing down. All right, so that's number 1. In number 2, question is this object in the diagram speeding up, slowing down, or moving with a constant speed? So the first thing you need to notice is the direction. So this object is actually moving from right to left. Okay, so if we're going to read it from right to left, we notice the dots start off pretty close together. So again, not covering much distance in that time interval. And as time passes by, it's actually covering more and more distance per time interval. In other words, it's getting faster and faster. Okay, so in this case, this object is speeding up. Again, the reasoning is dots start off closer together. That's a slow speed. They get further apart, so it's moving faster at the end. Number 3, which object is moving faster, and how do you know? Well, as you know, the closer the dots are together, the slower the object is, because it's not covering as much distance per time interval. So knowing that, A must be traveling faster because the distance between the dots is further than the distance between the dots in B. It's covering more distance per time interval. All right, let's go to the back. So this next one, a car approaches a stop sign and slows to a complete stop at the stop sign. Leaving the stop sign, the car increases speed. So let's go ahead and draw a ticker tape diagram of that car's motion. So I'm just going to say at the beginning, this car, as it's approaching the stop sign, is moving at a constant speed. Okay? And then it's going to slow to a complete stop at the stop sign. So since it's slowing down, it's now going to be traveling less and less distance as time moves on. So I'm going to make these dots a little bit closer together until it's at a complete stop. Okay, so I'm going to use that dashed line as a stop. Leaving the stop sign, the car increases speed. So we're starting from a stop. We're going to gradually increase the speed, which means that the distance between the dots is now going to get further and further. Okay? Number 5, a car is traveling on the freeway at 65 miles per hour. The driver sees brake lights in the distance and presses on the brakes slowly at first, but then has to slam on the brakes. So it starts off at a constant speed of 65 miles per hour. So I'm just going to draw dots pretty far apart. So that's 65 miles per hour. And then what happens is the driver sees brake lights in the distance and slowly presses on the brakes. So initially, the distance between the dots doesn't close too quickly, but then he has to slam on the brakes. So in that case, we're rapidly changing from a far distance to a slow distance. Okay? or a smaller distance. So here's a slam on the brakes. And then there's a stop. All right, number 6, write a story to describe the motion in this ticker tape. So the main thing you should take away from this is that in each of these 3 sections, the object is moving at a constant speed. The space between the dots is the same, okay? But if you pay close attention, you'll notice that the spacing between the dots actually increases from section to section. So, for example, I can say, I'm driving in my neighborhood at 15 miles per hour constant speed. I go to a stop sign, and now I'm driving at a constant speed on the local road. And then after that, I get on the freeway, and I'm driving at a constant speed on the freeway, like 65 miles per hour. Okay, so I'm slowly increasing my speed. You don't see that change in speed, so you can just assume that's happening at these little dash marks. Hopefully that helps. Any story can work as long as you're showing constant speed, but increasing on each chapter. All right, thank you so much for watching. Again, I hope this helps. If you have any more questions, you can ask us in class. See you in class. Bye.